We were looking at this question related to a continuous random variable where we first found k, which turned out to be 1 by 4. Then we found probability x is less than 0.3 and probability x is greater than 1.2. We now want to look at part D and E. Now for this, let's recall. For any continuous random variable x, probability x, for any continuous random variable x, probability x is equal to 0. This is the probability the continuous random variable takes a specific value. This is what we call point probabilities. The probability is equal to some exact specific value. Point probability. Right, so this is what we call point probability. Now, why is that? Now, let's just quickly recall why is it that point probability is a 0 for continuous random variable y. Now, a continuous random variable takes a continuous CRV, just continuous random variable, takes a continuum of values. By continuum value, we mean that it takes uncountably infinite values, takes a continuum of values. So chances of any one point so low that almost become equal to 0. So based on this, just based on this fact that we know for a continuous random variable, the probability takes any specific value 0. So we know the probability x is 0.8 is 0. So this is part D. And for part E, similar to part D, the probability that x is 1.2 is almost right. So for any continuous random variable, we know what the probability takes on any specific value 0 regardless of what the value is. So in general, probability x is equal to small x is 0 for any x, right? Yes. So this is basically in general for a continuous random variable x, probability x, the random variable, continuous random variable x takes on any value small x is always going to be 0 regardless of what the value small x is, because for a continuous random variable, point probabilities is 0, but this is not true in a discrete case. In discrete case, we don't have point probabilities. For a continuous random variable, we don't have point probabilities.